You know that incredible, unmistakable sense of a fresh rose? Of course you do. It's one of those things we can all recognize in an instant. But behind that simple, beautiful moment, there's this fascinating scientific journey. One that starts inside a plant's DNA and ends right inside your brain. So, come on, let's peel back the petals and see what science has been hiding in there.
So, have you ever really thought about it? What is actually happening when you lean in to smell a rose? Like, what are you smelling? It sounds like such a simple question, right? But the answer, well, it takes us on this wild ride through chemistry, genetics, and even atmospheric science.
For starters, the first thing you gotta know is that a rose's scent isn't just one single smell. Nope, it's actually this incredibly intricate mixture, like a carefully crafted cocktail of dozens of different chemical compounds, all working together to create that one perfect aroma.
So let's put on our detective hats for a second and break down this secret formula. What exactly is in this cocktail?
Okay, get this. One big study looked at 32 different kinds of roses, and they found that the scent wasn't just made of a few key ingredients. They found a grand total of 80 distinct volatile compounds, all packed into the fragrance of the petals. 80!
These little guys are called volatile organic compounds, or VOCs for short, and the key word here is volatile. All that means is these tiny molecules can easily turn into a gas, escaping the petal and just floating through the air on a journey straight to our noses. That's literally what a smell is, molecules on a mission.
Now, I know this looks a little complicated, but don't worry about all the tiny details. Just look at those two big donut charts on the right. See? Even with 80 different compounds in the mix, they show us that pretty much all of the scent, we're talking over 93% of it, comes from just two chemical families, monoterpenoids and benzenoids. They are the real heavy lifters of the rose's fragrance.
And if we zoom in even closer, inside those two big families, we find the four main superstars. These are the molecules that really do most of the work. You've got geraniol, which gives it that classic floral note, citronellol for that fresh kind of green element, and then the two that really give us that amazing sweetness we're all after, β-Phenylethanol and Linalool. Okay, so now we know what the chemicals are. But the next obvious question is, how in the world does the rose actually make them? To answer that, we've got to look a lot deeper into the recipe that's written in its DNA.
You see, a rose's scent isn't just some happy accident of nature. It is a precisely controlled, genetically programmed trait. The instructions for making that perfect scent are written right into the rose's DNA.
All right, another one of these complex-looking charts, but the idea is actually super simple. Think of it like a recipe. Up at the top, you have your basic ingredient, sugar, which the plant just makes from sunlight. Then, specific genes act like tiny little chefs, directing a whole series of chemical reactions that transform that sugar, step by step, down these different pathways to create the final, fragrant molecules that we smell. And hey, this isn't just a theory, it's a fact. Scientists have actually gone into the rose's genetic code, and they found the exact genes that are responsible for making those superstar molecules we just talked about, specifically the ones that create that beautiful sweet aroma. We even know their names. The gene RRTPS1, that one's the master chef for linalool, creating that sweet, lily-like scent. And meanwhile, the gene pair RRAAT1 and RRPAR2, they work together as a team to produce β-Phenylethanol, which is that classic sweet rose molecule. So how can we be so sure? Well, check this out. This is the proof. Scientists ran this brilliant experiment where they basically turned on these specific genes in the rose petals. And look at the result. On the left of each chart, you see the gene activity go way, way up. And on the right, boom, the production of that sweet-smelling molecule just skyrockets. It's the smoking gun, a direct, undeniable link between the gene and the scent. Okay, so the rose has followed its genetic recipe. It's released its perfect chemical cocktail into the world. But the journey to our nose isn't a straight line. Here comes the plot twist. The second those scent molecules leave the safety of the petal, they enter this totally new, chaotic environment, the atmosphere. And the air, with all its humidity and ozone, it isn't just a passive carrier, no. It's an active chemical reactor that can actually change the molecules as they fly. Now, not all the scent molecules get messed with equally. It all comes down to their shape. Think of it like this. Some molecules have a weak spot, an exposed chemical bond that's just hanging out there.
acting like a big target for the atmosphere to attack. You can see it there on the left. But other molecules, like the one on the right, have their bonds all tucked away and protected inside their structure. It's that vulnerable, exposed bond that lets the atmosphere change the molecule. So what happens when the atmosphere attacks? This graph shows it perfectly. Look at the bottom axis. That's the humidity going up. Now look at the vertical axis. For those vulnerable molecules like limonene, the amount of new particles that get formed from these reactions more than doubles. The scent cocktail is literally being remixed in midair. So the scent has been brewed by genes, released by the petal, and then totally changed by the air. So what happens at the final stop on this incredible journey? I mean, this is the big question, right? If the molecules are changing so dramatically on a humid day, does that mean a rose actually smells different to us? And here is the truly surprising twist. The answer is no. Despite all that chemical chaos happening in the air, a study in a controlled climate chamber found, and I'm quoting this directly, that the sense of smell is not strongly affected by ambient temperature and humidity. Wild, huh? It turns out, even though the chemical signature arriving at our nose is different on a humid day than a dry day, our brain and our olfactory system are robust enough to process all those different signals and still perceive the exact same consistent rose smell. Our biology provides the stability that the atmosphere just can't. So let's just recap this amazing four-step journey. First, the rose's DNA writes the recipe. Second, the flower brews this complex cocktail of over 80 chemicals. Third, the humidity in the air messes with and alters that cocktail in mid-flight. And fourth, our incredibly robust sense of smell filters through all that noise and gives us a consistent experience anyway. So in the end, that simple act of smelling a rose is really a story of two opposing forces: the incredible, ever-changing chemical complexity of the fragrance itself, and the remarkable biological stability of our own perception. It really makes you wonder, doesn't it? What other simple, everyday experiences that we totally take for granted are actually hiding a whole universe of complex science, just waiting there for us to lean in and take a closer look?